I know. I'm
okay. Share your screen. Hi everyone. This is my first time ever going live, so please let me know if you can see us and hear us. It is. Oh, look at that. We have 10 people. It is so windy. We have the most beautiful view right now. Can you turn the screen down? We've got bluebonnets. It's Texas Hill Country. Okay, look at these hills and these lakes. I don't know how long it's picking that up, but we are waiting for the weather to clear. Yes, you can see that it's just white up there in the sky. So we are kind of waiting for the clouds to clear out for right now. Ultimately, we can't launch unless there's less than 50% cloud coverage. But in the meantime, we're gonna go ahead and get started, getting all the flight lines set up, and we'll just hold off on the balloon part itself. So let me, if I can figure this out. All right, I can watch all the setup. Yeah, feel free to ask questions in the chat and all of that. Everybody can also get their very own minifigure from the flight. So if you go to the oh gosh, what is it called? The informational part of this below the live stream, the description. Thank you, Lauren. You can go and view our fundraiser page and get your own minifigure. We are still trying to target a 12. Maybe a little bit after 12 now, based on cloud coverage launch time. So we'll be sure to keep you all updated here. But yeah, you can kind of just tune in and we'll walk you through and talk you through what we're doing as we're doing it. Let's talk about the NOTAM. So what is the actual in order to make this legal with the FAA? Oh my gosh, yeah. So in order to fly a high altitude balloon, you have to file a NOTAM for both launch and landing. So and a NOTAM is a notice to airmen. So essentially, we have to call the FAA and say, this is the latitude and longitude that we're launching from. This is the altitude that we plan to get to. This is the direction it's heading, and this is the times we're expecting it to launch and land. And you have to get permissions to do that in the launch location and the landing location. And since this balloon is a little windy today, is going a little bit farther. It's crossing a couple different airspaces, so we also have to get a pointer NOTAM, which helps cover all of the space in between where we're flying today. Let's make sure everyone can hear us because it's windy. I can't. It is very windy. And we're standing. Hi, Lauren. Hi, Susie. Hi. Can you hear us? Okay. No, let us know. But, okay. My sound isn't on, so I can't hear anyone else. But I guess I can't hear you. Great. So you were checking winds aloft, and you have an ascent rate. How did you figure out? Yeah, so there's a bunch of online calculators. I can try and drop the link in here. Very windy though. I know it is very windy. This is not standard Texas. It feels like it is cold and windy and cloudy and we live in the desert. It was the opposite of yesterday. Yeah. What is going on? So yeah, I've been running the flight prediction models all week based on all of the weather models being inputted into it. So I put in our expected burst altitude, our ascent rate, our Latin lawn of where we currently are at this really gorgeous vineyard, and it predicts where it's going to burst and where it's going to land from that. So yeah, and there's all kinds of other things that we were talking about earlier that have to be considered. So part of why the balloon has to be launched in that 50% cloud cover is for the other pilots, for the safety of pilots. It is definitely breaking up. It is. I see more. I see sun. Sam, look at this. Look at this sun coming through the clouds. Right there. It's just generally brighter now. It is generally brighter. It is brighter. I'm really hopeful. I'm hopeful. There. Susie, I want you here too. Fun fact, you can also donate directly through the live stream somehow. I know that I set it up, but I trust you all and your tech savviness to figure that out. But you can also donate through the Give Butter link in the description as well. I think we're going to get started on some flight line stuff, so either you can take it over or I can. I think it'd be cool if we talk through what's in the boxes. And I'm going to turn the computer because this view is just incredible. I'm a big nature girly and I'm what? There's an incredible vineyard over there too. Probably can't see that, but I want to come back here and sip wine. So it's gonna let you guys just listen in to the. Everything's gonna work out. Okay. Yeah, that's probably true. We could probably ask the vineyard. Yeah. So what is this camera? This is my very janky reflector. So essentially every high altitude balloon requires something kind of like this. You can order them online, or you can do the complete DIY route that I did, which was laser cut a bunch of circles, glue them together, and then like glue and tape a bunch of aluminum foil over it. And it ultimately just serves as a radar reflector for other airplanes and other things that will be flying in the area that we're flying. Yeah. You actually would probably know more about how that works than I would.
This is like the opposite of what like the F-117 was trying to do, where it like minimizes its radar cross section. This is like trying to get the balloon on the radar.
This is what came with the inflator, that and that. You see that? Yeah.
So the balloon's going to be inflated with helium, which is a question I asked earlier, which it's kind of obvious, right? But who knows?
No, there's a couple of like different
there's options, right?
Yeah, there are options, but helium is the cheapest, I think, of all the options and the most easily accessible, since you can get it at any like welding supply store, which is what I did yesterday. So if you were following my stories yesterday, you saw me like drive to Round Rock, which is like 20 minutes from my house, and then all the way to a town called Colleen, which is like an hour from my house, because there's a helium shortage. And yeah, so I had to drive to a bunch of different places to try and find helium, but we did it. And the guys, they were like so excited for this too.
What's also like super interesting is one thing I didn't know. I've launched a weather balloon once, but I wasn't actually part of coordinating it or what was happening. But it's really interesting that there's actually a transponder on board, and there are obviously FAA requirements that you have to abide by and to keep safe and make sure you're not crossing into any airspace, which can be difficult because it's up to the wind. So that's why Kaylee and the team were monitoring the wind so carefully this morning and winds aloft, looking at the forecasted radar for cloud coverage and for the precipitation too at the different altitudes that we're going to be crossing through. It sounds like if we're below 60,000 feet, we have to have at least a 50% broken cloud coverage. And above that, it doesn't matter as much. So we'll be monitoring that. But as far as some other things that are, I'm just looking through the case of things in here. There are several GoPros that are going to be on board. So that's going to be really cool to capture actually the edge of space of what we're going to see today, and get that down here on the ground. There's also a flight computer on board, and a termination system as well. Kaylee, is this a manual termination, or does it just burst once?
Yeah.
Okay.
So once it gets like too far up in the atmosphere, it'll burst. We're targeting about 100,000 feet. I think we're gonna get really close to that because we're currently at like 1,200 feet. But because our payload is so heavy, we have like a 12-pound total payload, 2 6-pound payloads, so that we're staying within like FAA requirements. But the burst altitude that I got was about 96,000 feet this morning. Okay. So, and that's without the altitude. So we're going to get really close. It's going to be a nail biter.
1,200 above.
Yes.
Okay. So do you have the payload? Like, can you show it?
Yeah, that's what I'm looking for. Where are my minifigures?
Okay, let me see if there's any questions. Susie, you're going to become a Lego astronaut today. Athena, so are you. We miss you. Carmen Line Slay. What? Our payload is somewhere else right now.
It's in another car. Okay, so fun facts about the payload though. So I was kind of saying it a little bit earlier. So we have to have 2 separate 6-pound payloads. And this is because of the FAA requirements when it comes to launching high altitude balloons. Your payloads can't be over 6 pounds and you can't have over 12 pounds total of like everything besides your balloon. So that includes the flight line, your parachute, everything. So the way we're doing this so that we can get all the minifigures up, because if you've ever weighed a minifigure and if you've been watching my stories, you've known I've weighed these about 1 million times. They weigh quite a bit, especially when you have like 1,000 of them. And so what we did was one payload is exclusively, it's 100 minifigures standing up on a like board. We're gonna have the GoPros on there, the flight trackers and all of that on there. The reflector above it. We have, like I said, we have our GoPros that'll be on there. We have something called a spot trace, which is a GPS tracker. And then our flight computer, which will give us our like final altitude readings and like show you. It's an Eagle flight computer, which will give us our final like altitude readings in addition to like temperature sensors and all that kind of like more fun science stuff to learn about our payload. Our flight. Yep, this is our parachute. Nice bright red and orange. Might be some yellow in there.
Did you have to pack that, or how did that work?
No, they packed it.
They packed it for you. Okay.
But we're gonna like fold it up and tie it like this is not how it's gonna launch.
Okay.
Yeah. Yeah, so we have two separate payloads. We're getting one now, but the other one is just this box, literally like filled about half of the way up with like 1,000 minifigures or 900 minifigures since 100 are on top. And we're gonna saran wrap this to keep them all enclosed and use these as like the handles on the sides to secure them during flight. And this is exactly like 5.9 pounds. So we are just under like that requirement. And our other one is a little bit lighter, just so we can make sure that we have plenty of space for electrical tape and things like that to secure all of our flight computer and GoPros and all that fun stuff.
So this box itself is literally flying to the edge of space.
It is.
Okay, so we're going to saran wrap it so that it stays correct. Okay, so when you said flight line earlier, what does that mean?
Yeah, so this is our flight line. It's literally just like 50-pound fishing line. There's a 50-pound requirement, so ultimately like means that it has to be able to break in like a rough scenario, so that like the balloon doesn't like go crazy. And so that's it. This is our flight line. It's going to be connected to all the boxes. It'll be what connects us to the parachute and the balloon, and the payload that'll sit about 10 feet on top of this one as well. I can't like read all these comments, but I think it's just Susie saying hi. Hi, Susie.
Anyone we're honoring today? Yes, we are. So
Yes,
Kaylee,
they're about to
show
have
us.
them.
The payload is coming, but also, let's see, any famous scientists or women in STEM?
So yes and no. So a lot of these I think were in general based off of like we picked roles that were based off of people that our team admired a lot. So like the reason why we have like an engineer and a biologist and a chemist was because like there were scientists in those fields that we loved or like we found as like personal role models in history like versus others. So yeah, so like our astronauts, I know we had a bunch of like Mae Jemison fans and all the new Artemis missions, so we picked astronauts. We have
I'll do like a close up.
yeah. We have a lot of engineer friends, so we have engineers. Most of like the women in history from like our team that we know and admire are like on the chemistry and biology side.
Oh, this is cute. It's got like a little Saturn shirt.
Yeah, that's our astronomer.
Oh, the astronomer.
I like how some of them are
This
just
is an astronaut. Yeah, another astronaut.
And then yeah, let's see. Can I have
the payload? Yeah.
Let's show the fun payload.
So if you saw my stories yesterday and sharing what Reinvented was sharing, these are the special dedicated payload minifigures.
So we have all the special ones up front. I'm going to start with this one really quick because we're actually going to be hosting a fashion show in July. And one of our designers is like in love with 3D printing and really talented. And she actually 3D printed herself with a little wrench and a 3D printer. So like this minifigure is the only like 3D printed minifigure on here of Dora. And I'm like so hyped for that. Then we have Dr. Kimberly Fiak over here. Unfortunately, Kimberly, if you're watching, I didn't have like a Lego brain, so I gave you a little like flask. But I know you're like, you're a pathologist and you work with brains, so I'm gonna try and work on that when we recover her. Then we have Lauren over here. Lauren, she has her little telescope because she has been doing a lot of really cool astrophotography lately. Susie, donning her Prada bag, which like you can probably kind of see right here in the middle, and her wrench since she's a mechanical engineer by degree. Athena, who's wearing like the James Webb shirt with her telescope as well, because she also is like big into astronomy. We have Kate, who's wearing her little flight helmet here with her flight suit. We have Ruth over here, who's one of our board members and a huge advocate for girls and women in STEM, especially when it comes to closing accessibility gaps, when it comes to like funding and low income. And then we have Joan, who's also an engineer at NASA, doing really awesome stuff. And we have two astronauts donning on either side, so it's gonna be fun. And then as you can see, we have 100 others. Our flight computers are gonna sit back here with our flight computer on one side and our spot trace or GPS tracker on the other. And then down here we're going to have down here we'll have our GoPro so we can get a really awesome shot of minifigures.
And if you're just not tuning in, this is the flight computer and some other parts over there. I'm not gonna mess with. I don't want to mess anything up. Okay, so is this the first weather balloon you've launched?
It is the first weather balloon I've ever launched. So you are all here for Kaylee first.
This is exciting.
It is like the hackiest looking thing I think I've ever built in my life, as you can tell. But I'm hyped. Okay, I'm gonna go help with the propulsion stuff and see if I can get started.
Cool. Well, you're gonna hang out with me for a while, but I'm gonna keep digging through this box of stuff. Do you want to come be on the live stream? I know. So I think earlier, yes. Hi. Oh God.
Yeah, I'm ready.
Let's see. So excited for the GoPro images. Yes. So excited.
Them this morning, and if you want to see what like the angle of the GoPro looks like with the funny face, you can go check out.
Okay, so Kaylee, if you didn't hear that, is saying to go look at her stories because she tested them out this morning with the angle. Let's see. Is the flight computer an Arduino? No. It's from highaltitudescience.com. Eagle flight computer. There we go. It's pretty cool. Knots. No. Not like the fancy knots. We are learning how to tie special knots right now. Athena and Susie, yay! Exciting. Do you want to talk a little bit about what you do? You don't have to, like your background or...
Hi, everybody. I work with Kaylee at Firefly Aerospace. I'm the office manager there at the spacecraft location where I'm here in Cedar Park. And I'm actually an accountant. So I started at Firefly almost 3 years ago as an HR in HR, and then moved over to the accounting team for a year. And a little over a year ago, this office coordinator position came up, and I'm just having the best time. Just running, we do get a lot of visits, and so just coordinating everything when people come in, food, events, and a lot of employee appreciation stuff. So I love Kaylee, and I, really support her her nonprofit, and we've done a couple of getting Fireflies to help out with a few things in the office, and I'm just really excited about this. It just seems like a lot of fun. I mean, who doesn't love Legos and women
and weather balloons?
Weather balloons! Oh my gosh! And I went to A&M for a little bit, so heading towards College Station. It's a beautiful drive. Excited to go see that ride as well. So
yeah,
I think it's gonna be a really fun day.
Yeah, I'm excited. I think it's starting to get brighter. I think the clouds are finally supposed to. They're moving south, so winds aloft are actually much slower than like surface winds right now. Which, well, for us that doesn't really help. We need the clouds to move.
Yeah.
You said earlier some of the models show that it could end up in the Gulf of Mexico, but we're not doing that anymore, right?
Oh, yeah. So, a fun thing I've learned through all this about Texas is that, like, the wind models here vary pretty significantly. So, like, the difference between today and tomorrow was pretty drastic. And the difference between, like, this week and last week also very drastic. There's, like, very little consistency with the wind here. And so, like, when I was starting to run this and trying to plan out a launch and a landing site, there were some days where it literally was so windy that it would bring it from Austin all the way out to like the Gulf of Mexico past Houston, which was crazy. So when we like started narrowing down dates, we were really hopeful for this date, and I'm glad that it really worked out. But obviously, like, the winds were going to play a huge part. So if that was like the scenario that we were going to see for today, we would have changed our launch date. But today we're going to end up like 2 to 3 hours east, a little north of College Station, which is significantly better and involves no boat recovery.
Although that would have been a lot of fun.
Would
I
it?
could get my scuba gear out, and
yeah, you and James, you could have scuba in the Gulf.
Maybe next time.
Yeah.
Okay, so I'm gonna bring the computer over, and we're gonna look at what you're doing because they're getting this set up and doing like some of the actual technical hardware put together. As you can see, the clouds are like they're starting to break up. Okay, I'm gonna film this. What are we doing here, guys?
Yeah, so we're just looking at all the inflator gear that we have. So we received like our hose and some inflators from High Altitude Science, and then we also got this regulator from the people who provided us with the helium tank. And ultimately what this is going to do is just like help us regulate how quickly the gas comes out of the canister, because if it comes out all at once or really, really fast, that's a huge problem, because then our balloon will burst really quick or degrade its performance. So we're going to fill it up like relatively slowly so that we get the best performance out of the balloon possible and the least dangerous like balloon filling experience.
How high of pressure and how much helium do you know to put into the balloon to get the altitude and performance you want out of it?
Yeah, so there's another like balloon calculator online that helps to some extent. So you're able to vary your like what you're looking for in terms of like burst altitude and ascent rate, which is really important because you don't want it to go too slow, because then my GoPros are gonna like just die, and you don't want it to go too fast, because then you won't get as far up. And so I like targeted an ascent rate around 4 meters per second because the average was like 4 to 5, and wanted my burst altitude to be as close to 100 to 1,000 feet as possible. And from there, it actually tells you like how much positive lift you need. And in grams, which we'll have to convert to newtons, so we can use our little lift gauge here, which shows you. Oh, it actually shows you in grams on this side.
So you don't have to convert
learning.
it. Okay, that's great.
Thank you, internet. And how many cubic feet of helium we need, which is about 250 cubic feet of helium. So like literally, we're gonna empty out this whole tank. This is a lot of helium for a high altitude balloon flight.
I don't know if you guys saw.
Yeah.
This tank is huge. It fills up like an entire SUV.
Yep, but it's because our payload is 12 pounds, so we need a ton of helium to carry the weight.
So are there different sizes of balloons for, I guess, different like payload weights depending on?
Yes.
Okay.
So I think the smallest I've seen is like a 300-gram balloon. Ours is a 1,500-gram balloon. So it is like definitely very much so on the larger side. It is meant for like larger payloads or if you want to get really high. So yeah, and I kind of did a trade between a 1,200 and a 1,500. If I did a 1,200, I probably would have launched 2 separate balloons, so that we could still carry like all 12 pounds. But the 1,500 made more sense because then I could just do one balloon, keep it nice, easy, consolidated, and like less stress.
Yeah. Yeah, so for anyone watching this who wants to do like their own at-home balloon, like this is something that's safe to do at home as long as you know what you're doing, right?
Yeah, absolutely.
How would you say that someone should get started, or where should they start looking?
So Sam here sent me a bunch of really awesome links when I was first starting and mildly freaking out. Over the Horizon is a really good online resource. They have a ton of tutorials and how-tos. Those are pretty understandable and instructable as well. And High Altitude Science is where I got most of the parts from. It's run by like a really, really awesome dude with like a lot of experience in mission control in like at Johnson, but has done like weather balloons like a lot in the past. So he helped me pick out like all the gear, and we got a lot of stuff from there. And they also have like how-tos and tutorials on how to use all that gear and like regulations and all that fun stuff too.
Yeah, because you do have to follow FAA regulations. You can't just like fly something to the edge of space.
Honestly, that has been the trickiest part of this, is trying to understand what NOTAMs we have to file and all the FAA regulations related to like cloud coverage and winds and the reflector and what size that needs to be and all that kind of stuff. But there is a ton of resources online to help with it. So it's very beginner friendly, and obviously you don't need to launch 12 pounds right out the gate because 1,000 minifigures is maybe a little crazy. Most people like will launch a GoPro and like some one little thing and still have like amazing, awesome footage and like get much closer to 100,000 feet, which is great. So
yeah, what made you choose 100,000 feet?
So 100,000 feet is, I think, the standard altitude used for edge of space, and that was what I was trying to go for. I don't think any of you are going to penalize me if I hit 96,000 and come like 4,000 short. I hope. Hope, guys. But that is the goal. That was like what I've been trying to do all the calculations to for like the past couple of months while we've been planning our track.
That's awesome. So how'd it go? What's next? Did you figure out the regulator stuff?
Working on it.
Working on it. We are working on the regulator.
Okay. Why don't we go ahead and start drilling holes in the
I'll go through the
thing,
questions,
and we
guys.
can, start zip tying down.
Thank you. Cheers to the first balloon launch. Everyone says cheers.
Thanks, guys.
Cheers.
We can start drilling
Hi,
holes in the zip
Joan.
ties and get all the other stuff zip tied down and start adding more.
Okay, we're gonna
holes to the
prepare the
GoPros.
payload, it sounds like. Okay. We'll go back over and start prepping the payload. We also have a lot of other stuff like the saran wrap that you missed earlier. So this is the payload, this box right here, as well as this. These are the dedicated Lego minifigures, and the flight computer and instruments are going to get attached to that. So I'll show you guys. Sorry, this is really bright. I can't see. Okay, yeah. So the flight computer is there, and that is what Kaylee is working on now. Kaylee, what are you doing to the flight computer?
Yeah, I just need to connect the battery to the flight computer. So the battery's in. We just have to like loosen the screws, put the 2 wires in, and then we're gonna zip tie and like duct tape it down.
Okay.
But I don't know if I have it right.
So did you find an 8 gig micro SD or?
Yeah, Xylos was already in here.
Oh,
And
awesome.
I just didn't notice.
Okay, cool.
And it's 2 gigabyte. I don't know where the heck she found that.
Okay, yeah, I couldn't find anything smaller than 8 gigs. Last night we were having an issue trying to find the proper micro SD card, and I couldn't find anything less than 8 gigs. And I almost had to drive like 3 hours to find one, but all is good. And it's powered by just AAA batteries, which is super, super cool. So how much was that flight computer? Just for people who are like wanting to do this themselves, what
This
cost?
is about $120.
Okay,
So
$120.
it's a little expensive, but it is like specifically designed for high altitude flights. So
Okay.
you won't have to worry as much about like the extreme temperatures, which is like the big concern as it gets really cold up there. That's like our big concern when it comes to the GoPros, is the GoPros might stop working if it gets too cold. So that's why we have 2 on board. But yeah, we're gonna try our best because I forgot a screwdriver that fits this.
Yeah, that's interesting because okay, so in undergrad, I don't know any other aerospace undergrads here. We had to build a standard atmospheric model in MATLAB, and the atmosphere is standard up to like 85,000 feet, and after that, you start seeing fluctuations in like density and temperature and everything, and it becomes non-standard. So I don't remember. I don't. Do you know what temperatures we're going to be seeing at about 100,000 feet?
I don't know.
Okay, we don't know.
Negative Celsius.
All right, it's cold. It's very cold. But then once you start getting into like the thermosphere, it starts getting really hot again. So the atmosphere is really interesting once you get to high altitudes. But yeah, this is like a really cool project. It's something that it seems like it has a very low barrier to entry. The cost of the instrumentation is not too bad. And it sounds like there's a lot of accessible open source resources for launching your own weather balloon. As long as you just follow all the FAA rules and do everything carefully and safely. Of course, we have unknowns like this weather right now, and we have to launch it within our launch window per the NOTAM that Kaylee filed with the FAA. So we have until 2200 Zulu, you said?
2030.
2030 Zulu.
2030. But the later we get, the windier it got. So we want to try and launch as close to before 1 o'clock as possible.
Okay, so we're fighting the winds and the time right now to launch within this window. Hopefully we don't have to scrub, but we'll keep our fingers crossed, and I will show you as they're putting the payload together.
You get it? Oh, okay. Now I gotta remember, red goes to positive. Oh yeah, I didn't realize you could take it out.
Is the flight computer recoverable or is it expendable?
Recoverable.
Okay,
Everything on here is recoverable,
that's even better.
other than the balloon, obviously.
Yeah.
We're getting real janky here, guys.
Using a zip tie as a little mini screwdriver, but it works, I think.
I think I can electrical tape over it too, just to like make sure. Oh, what's our cloud coverage at?
I'm pulling that up actually. So like, which area of Texas are we in?
We're in Vernon.
Vernon? Okay.
Yeah. Like Lake Buchanan would be like the good reference.
Hello.
It's like right there.
If you're just now joining, we are at our launch site. We are waiting on the weather to clear up a little bit. We need at least 50% of this to break at 60,000 feet. And we are fighting like winds aloft as well as a window for the NOTAM that we filed with the FAA. And Kaylee is putting together the flight computer now onto the payload. All of this is flying to the edge of space. And it is all recoverable, which is,
Yes. That's the goal, at least.
the goal is to be recoverable. Yes. This one's not falling in the ocean. is one of the fun parts of engineering and these kinds of projects is you get to get really creative with how you put things together and making things work in the field.
Yeah. We forgot a screwdriver, guys. But I brought like literally this whole pack of drill bits. So I feel mildly prepared.
I'm gonna set this here so that we can just get like a continuous live stream of the payload getting put together.
I'll just jump on to remind you all too that this is all part of a Women's History Month fundraiser for Reinvented. So if you have not already, please go check out our fundraiser link using it's a givebutter.com link in the description below. You would also donate directly through this YouTube live stream. I don't totally understand how to do it, but I hope you all tech savvy people on the internet do. Yeah.
Check the description.
There's a little button like in the comment, like in the chat area. And you can actually get your own minifigure by donating. So once these get recovered, we already have a ton of donors who have like contributed to our mission and to the fundraiser for Women's History Month, and they are all going to receive a flight-proven minifigure once we get them back. We good? I see a green light and a blue light showing that we're getting data, so that is looking good to me.
What's the data coming from? What does that mean exactly?
Yeah, so the data that we're getting from the flight computer is more accurate reading of the altitude. So we have something called a strato track, which is our like radio transmitter. So we will get some altitude data from that. However, this flight computer is significantly more accurate, and we're only going to know after we pull it back down and are able to like put it in the computer. We're also going to get temperature data. Our temperature sensor is right over here. If you want to like,
I will bring the computer closer. You can check out this instrument.
Yeah. So we have our temperature sensor over here. This is the flight computer here. There's an SD card in the back, a 2 gigabyte SD card, which is like ridiculously tiny, but it's like an old school flight computer. And yeah, we're gonna get altitude data, temperature data, and I think the strato track gets pressure data. So we're gonna have a good amount of data. But the main thing we want from here really is the altitude, because our strato track is going to only give us the basics, and in order to know if we reached 100,000 feet or not, like that'll be key.
Yeah.
Okay. I'm struggling.
Incredible. I can help you. We are gonna electrically tape whatever. It's electrical tape.
It's
We're
electrical
gonna tape
tape,
it.
guys.
This is oh wow. It's always that first piece that's like, jeez. All right, there we go. Do you have scissors?
Yes.
Okay, great. I thought about that like after I got the tape. How are you taping this? Like wrapping it around?
I'm gonna like put really close your finger on that one, and then waiting for
Oh, just that.
yeah.
Okay.
Just this area for now to keep the wires in place.
I had no idea what this was for, and I texted Kaylee at like 6 o'clock this morning and was like, "Is 60 feet enough electrical tape?"
Okay,
was
so
like, yes.
So fun fact, the electrical tape is actually less for this and more for tying off the balloon.
Oh.
Yeah. But since we have it.
Yeah, might as well use it. Yeah. Okay, so this is what the weather balloon looks like, in case you're curious. It's literally just packed nicely in a box from High Altitude Science. So again, if you want to this seems like a really cool project you can do safely at home, as long as you like follow protocols online. High Altitude Science and Eagle Flight Computer. Some of the things you want to get. And what is that one instrument again?
Oh yeah, so this is called the Spot Trace. It's a GPS tracker, like a really fancy one. So this will not work after like a certain altitude because it's not meant for that, and GPS stops working once you get into space, kind of a thing. Well, not entirely true, but mostly true.
Yeah.
But this will help us give a much accurate reading once it comes back down. So the strato track helps us track it above like 15,000 feet, I think is where it starts to get better. And then this one is what will help us track it like mostly when we're like looking to recover it during landing, because this works very accurately on the ground.
And we don't really have control at all over where this lands. Like it's just kind of the mercy of the winds. So are we like anticipating having to just, I don't know, cross into a field potentially?
Yeah, essentially. So when I picked a launch location, I tried to base it off of the landing location, which was best case scenario, literally the middle of like an empty field. We didn't want to like be climbing mountains. We don't want to be near rivers or big cities. There was like a big solar power plant like over near Houston that was like a worry for a little bit, but now our trajectory is nowhere near because I picked a launch site out and burn it. So yeah, there's a lot that goes into picking all of that.
And like staying agile with
Yes.
the winds and the weather.
So
And
obviously where we land is not going to be down to the lat lawn
Yeah.
degrees, but
yeah.
hi
Cloud cover
is
it's going to be 60% at 1 o'clock.
We're getting a cloud cover update if you didn't hear that.
okay. What is it at like 1:30?
It doesn't go down to below 50 until 7. Go through like the thing.
We will see.
Like, do I fly? I think
we
it's
can
a lot
make a
better than it did
comparison.
when we arrived.
Yes, I do think that we should still like keep
Yeah.
a little bit. Oh wait.
Okay.
We're going to keep trying.
Yeah.
If you didn't hear that. So we need 50% cloud cover and
It's 60 now,
it's
though?
60 right
No,
now.
Right now it's 70. So
It's 70 now.
It can be 60 at
But we are fighting that launch window
forecast after 1
and the
o'clock
winds.
is
So
7 p.m. and that forecast is below 50. Like
Oh, so there's nothing in between 1 and
there's
7?
nothing in between 1 and 7.
Okay, so we just have to keep eyeballing this essentially.
Yeah, like eyeballing it. Right now we're at 100%. Like,
This is upset. Like, so according to the weather service, this is 70.
this is 70, right?
So we just need to see, like, let's break apart more.
and we have to follow this like carefully. We can't just like hope for the best to do it because it is an FAA regulation, and we want to make sure that we're not breaking the rules and that like obviously we're not sending anything up that's going to affect any pilot. We don't want to do anything that's unsafe, but we do have that NOTAM window that we have to launch within. And it sounds like there's a weather report. It's 7 o'clock showing it's going to dip down into what we're needing, but there's a couple hours of no information. So we're going to keep monitoring and keep going forward and putting the payload together and keeping our fingers crossed. Kaylee has a power tool in her hand now. So, Kaylee has a power tool in her hand, and we're going to watch that.
As I often do.
Yeah.
It's not yet. Okay. There we go. We're all just staring
You
at
got
me
this,
now.
Kaylee.
Okay,
Let's see
so
if there are any questions. Does anybody have questions on this?
can you like hold the outside? I think I can drill through here.
Okay, somebody asked, how is the percent of cloud cover determined?
It's a great question. Sam has found, what is it?
The National Cloud Cover Database,
Yes.
which forecasts the cloud coverage.
Yeah, so it's actual forecast.
Do I want to go on this way too, you think? Yes. Cindy says yes.
That's what I was looking. I'm like, you've got to go.
We do what Cindy says.
all the degrees.
Like, drop the GPS in a field somewhere and go, like, we got the GPS, we didn't get the payload.
We'll be. Pick this side is flatter.
Somebody is asking, once it reaches a certain altitude, are we able to see it from DFW?
That's a great
Will we be
question.
able to see it?
I think it's too cloudy. There is a reflector on it. It's really tiny. I can give you all like the call sign though, and they may be able to track
Yeah,
it that
This
way.
is going to be on with like air traffic control, and like there's a transponder on it. So, and we do have to notify air traffic control before we launch it and like give status. So that would be really cool actually if you can provide that.
You put two together.
We are trying to fasten this GPS device right now, and our zip tie is we're gonna zip tie
Well,
zip
you
ties.
gotta put it through and then around, I think.
Are you also gonna tape over that? Okay.
Super tight.
little loud because I'm also a space.
So she
employee.
works on a different lunar lander. Is that still okay? I think so, because we're commercial, right?
Or just the lobby even?
Yeah, you can have the lobby.
Okay.
I can probably show you the box. You can see it from the lobby.
Well, it's probably like on the internet, too, right? Like the advertised models and stuff. Yeah. I'm just like, it's cool to see more space stuff come further north in Texas. Forever, Houston was just like the space city, and now there's Firehawk Aerospace now in DFW as well. Yeah, the rocket engine.
James, I don't know what's going on here. I struggle. Oh, I'm just going through the wrong thing. It's so cold, guys.
It
I'm
is.
doing this for you.
It is very cold, and yesterday it was like rainy but warm. And then it rained, and then it got cold. And I wish I had my coveralls. I luckily brought this windbreaker. When I was getting up this morning, I was like, maybe I won't pack a jacket. Did you say the ascent rate was 4 meters a second or feet per second?
4 meters.
That's pretty fast.
Yeah.
4 meters per second is incredibly fast.
Alright, our GPS tracker is officially on. I'll go back and tape it in a bit.
Okay. So what else are we attaching to that board?
Flight computer has to get attached with this battery pack. So I gotta try and figure out what do you think the best way to zip tie this one is? Like this?
Yeah.
I want to cross that way. Okay. Can you or someone? I like this.
I can hold this side of it. Oh, thank you. So Kaylee is a Ryobi girl, right? Yeah.
There. Like move that out of the way a little. Move this up. I'm gonna do like one here. Okay. So I'm gonna do the
Cloud update.
We're getting a cloud update.
In 1 minute, we're getting a cloud update.
1 minute cloud update. Fingers crossed, everyone.
That's what we want. So we just want it to be lower than like 70 because then we know we're heading in the right direction. We know it's going to get progressively less cloudy as time goes on today. So, all right. So we got this. We'll do that. And then
Are you able to leave the batteries exposed, or are you going to wrap those in electrical tape?
it's going to wrap.
Yeah, I think that's a good idea.
Which maybe we should do first.
Probably. Easier, yeah. I'm going to wrap some of these components, especially the electrical stuff, just because we're going to be passing, there's some sort of precipitation probably. No, thank you. And electricity and water don't do well together, so. Answer any other questions. That would be really cool if we could see this weather from other places. But if you're in a place where there's no clouds and maybe you get binoculars out, and once we provide that like transponder and yeah.
I feel like the answer is no, though. This thing is like really small, relatively.
Yeah.
But you know what? I'm not gonna crush your dreams. If you want to get out there and look, like, you know, I'm gonna stop you.
Yeah, get out and look for it.
Go find my balloon. Commercial airlines flying. So commercial airliners fly somewhere between like 30,000 and like 37,000.
Yeah.
However, I've just been made aware that private jets apparently fly up to 60,000. I did not know that.
Like 51
Okay.
is the service ceiling, but yeah, that's the airspace. So yeah, like we have to keep in mind airspace requirements, and if you're not familiar with airspace requirements, the way they work, They are kind of like upside down buckets over airports, depending on what kind of air traffic you're looking at, if it's like a major international airport, if it's a smaller airport. And then when you're far away from any airport, there's something called Class E airspace, and that's also above, I think, 60,000, which is, I should know this off the top of my head, but so that is what we are targeting, and that's when we are looking for that less than 50% cloud cover. Under that, once we're above that, we're okay. And that's where we are out here now. Yes, we're gonna fix this on.
Yeah, maybe get a couple angles like this. Great. All right, can you help me with the zip ties again, James? Sam, update. Okay. Oh my God, it's loading.
How are they making these measurements? Are they sending them weather?
I genuinely want to know.
Sounding rockets? How are they doing?
Okay. So I have one here, one there, one across, and then I have 1, 2. I don't know. Maybe this one, because then the other ones can go over it.
Yeah.
Ah!
No.
Send it!
Yeah. So we are at a forecast of 100% cloud coverage now, which is exactly how it looks. But we still have time. I don't know. The forecast is the forecast. Surface winds are picking up even more now too.
While we're doing this, tape electrical tape over like these ports.
Yeah, I can do that. Can I? Oh, like while they're attached.
Ah! Oh, where are they going?
Maybe bathroom? A glass of wine while they wait?
Yeah.
Okay, the ports, or do you want me to wrap around the wire as well? Like completely seal any electronic? Okay. Let's start this.
That's the goal.
Oh, wow.
They're off yet?
No, not yet. We're waiting on the clouds.
Well, our agreement was before noon.
Okay. Yeah, sorry.
Supposed to be in and out.
Yep. Okay. We can.
I know the weather's
Yeah.
just not working out.
We're hoping. Yeah.
But yeah, we have longhorns that roam around the park.
Yeah, that's what I'm saying.
And they're coming down.
Okay.
So this is where they hang out.
All right. Good
so
to
it might
know.
be challenging.
Yes, definitely.
So,
Okay. Yeah,
sorry,
we can.
y'all.
No worries. Thank you.
You're welcome. Is that Charlie?
Yeah, that might be part of our.
Oh, that is. Sorry.
This isn't. This isn't.
All right, guys, it looks like the clouds are not participating today, so I don't think we're going to be able to launch, and we're going to have to reschedule. But I will make sure to keep you all updated because obviously our minifigures are ready to go, and hopefully we're able to get this off sometime before the end of Women's History Month. But thank you all so much for tuning on, and I'll make sure that there's an updated link once we do get a new launch date. But yeah, so thank you guys for tuning in, and I will update you all soon. Here is my